Summary of Star Schema by Christopher Adamson. A review of data modeling techniques for dimensional data warehouses. Hello, and welcome to my channel, Data-Driven Decisions, where I review books on data and analytics. Today, I'm going to talk about Star Schema, a book by Christopher Adamson, who is a consultant and author specializing in data warehousing and business intelligence. Star Schema is a comprehensive guide to designing and implementing dimensional data models for data warehouses, which are databases that store and organize data for analytical purposes. The book covers the concepts, principles, and best practices of data modeling with a focus on the Star Schema, which is the most widely used and effective data model for data warehouses. The book is intended for a technical audience, such as data architects, data modelers, database developers, and business analysts who want to learn how to design and build data warehouses that support business intelligence and analytics. The book assumes some familiarity with relational databases, SQL, and basic data warehousing concepts, but it does not require any prior knowledge of Star Schema or dimensional modeling. The book is divided into 4 parts, which I will summarize in this video. Part 1. Dimensional Modeling Fundamentals. The first part of the book introduces the basics of dimensional modeling, which is the process of designing data models that capture the business context and meaning of data, rather than the physical structure or implementation details. Dimensional models are composed of 2 types of entities, facts and dimensions. Facts are numerical measures that represent the performance or behavior of a business process, such as sales, orders, or inventory. Dimensions are descriptive attributes that provide context and detail for the facts, such as product, customer, time, or location. Facts and dimensions are related in a star-shaped structure, where a fact table contains the facts and the foreign keys to the dimension tables, and each dimension table contains the attributes and the primary key for a dimension. The Star Schema is a simple and intuitive way to organize data for analysis, as it allows users to easily slice and dice the data along any dimension, and to perform aggregations and calculations on the facts. The Star Schema also has many advantages for performance, scalability, and maintainability, as it reduces the complexity and redundancy of the data and enables fast and efficient queries and loading. The first part of the book also explains the concepts of granularity, conform dimensions, surrogate keys, slowly changing dimensions, and hierarchies, which are essential for designing effective and consistent dimensional models. Granularity refers to the level of detail or specificity of the facts in a fact table, and it determines the scope and accuracy of the analysis. Slowly changing dimensions are dimensions that undergo changes over time, such as customer name, address, or status, and they require special techniques to track the history and preserve the accuracy of the fact. Hierarchies are logical structures that organize the dimension attributes into levels of increasing or decreasing detail, such as year, quarter, month, and day for the time dimension, and they enable users to drill down or roll up the data along the dimension. Part 2. Advanced Dimensional Modeling. The second part of the book covers some advanced topics and techniques for dimensional modeling, such as dealing with complex facts, multiple fact tables, bridge tables, role-playing dimensions, and mini-dimensions. Complex facts are facts that have more than one unit of measure, such as quantity and price, or that have multiple levels of granularity, such as order and line item. These facts require special attention and design decisions, such as splitting the facts into separate tables, creating multiple fact tables for different levels of granularity, or using degenerate dimensions to store the attributes that are not part of any dimension. Multiple fact tables are fact tables that share some or all of the dimensions, but have different facts or granularity. These fact tables can be related in different ways, such as using conformed dimensions, creating aggregate fact tables, or using factless fact tables to capture the relationships or events that do not have any measures. Bridge tables are tables that are used to model many-to-many relationships between dimensions, such as products and categories, or customers and segments. Bridge tables contain the keys of both dimensions, and optionally, some attributes or weights that describe the relationship. Role-playing dimensions are dimensions that play different roles or meanings for the same fact, such as date dimension for order date, ship date, or due date. Role-playing dimensions can be modeled by using aliases, views, or separate tables for each role. Mini-dimensions are dimensions that contain a subset of attributes from a large or rapidly changing dimension, such as customer demographics or product features. Mini-dimensions can be used to reduce the size and complexity of the dimension and to improve the performance and usability of the analysis. Part 3. Data Warehouse Architecture. The third part of the book discusses the architectural aspects of data warehousing, such as the data warehouse bus, the data staging area, the data delivery layer, and the data warehouse design process. The data warehouse bus is a conceptual framework that defines the scope and structure of the data warehouse, and the integration and coordination of the data across different business processes and subject areas. The data warehouse bus consists of a matrix that identifies the conformed dimensions and facts for each business process, and a bus architecture that describes the physical implementation and organization of the data warehouse components, such as the data sources, the data staging area, the data delivery layer, and the data marts. The data staging area is the component that extracts, transforms, and loads the data from the source systems to the data warehouse, and it performs various functions such as data cleansing, data integration, data validation, data transformation, data loading, and data auditing. The data delivery layer is the component that provides the data to the end users and applications, and it consists of various elements, such as the data marts, the data access tools, the metadata, and the security. The data marts are subsets of the data warehouse that are tailored for specific business processes or user groups, and they can be implemented as independent or dependent data marts, depending on the source and timing of the data. The data access tools are the software applications that enable users to query, analyze, and visualize the data, and they can be classified into different types, such as reporting tools, query tools, online analytical processing, OLAP tools, data mining tools, and dashboards. The metadata is the data about the data, and it provides the information and documentation about the data warehouse, such as the data sources, the data models, the data definitions, the data lineage, the data quality, and the data usage. The security is the mechanism that protects the data warehouse from unauthorized access, modification, or disclosure, and it involves various aspects, such as authentication, authorization, encryption, auditing, and backup. The third part of the book also presents a data warehouse design process, which is a methodology that guides the development and implementation of the data warehouse, and it consists of several phases such as planning, analysis, design, construction, testing, deployment, and maintenance. The planning phase defines the scope, objectives, and requirements of the data warehouse project, and establishes the project team, the project plan, and the project management. The analysis phase identifies and analyzes the business processes, the data sources, the data quality, the data users, and the data needs, and produces the business requirements document and the data warehouse bus matrix. The design phase designs the data models, the data architecture, the data staging area, the data delivery layer, and the metadata, and produces the logical and physical data models, the data flow diagrams, the data mapping documents, and the metadata repository. The construction phase builds and implements the data warehouse components, such as the data staging area, the data delivery layer, and the data access tools, and performs the data extraction, transformation, loading, and validation. The testing phase tests and verifies the functionality, performance, and quality of the data warehouse, and performs various types of testing, such as unit testing, system testing, end-test testing, systems testing, user acceptance testing. The deployment phase deploys and delivers the data warehouse to the end users and applications, and performs various tasks, such as data loading, data refreshment, data archiving, data arc access, data training, and data support. The maintenance phase monitors and maintains the data warehouse, and performs various activities, such as data quality, data security, data backup, data recovery, data tuning, data enhancement, and data documentation. Part 4. Dimensional Modeling Case Studies. The fourth and final part of the book provides 3 case studies that illustrate the application of dimensional modeling techniques to real-world scenarios, such as retail sales, inventory management, and procurement analysis. The case studies show how to identify and model the business processes, the facts, the dimensions, and the hierarchies, and how to deal with common challenges and issues, such as complex facts, multiple fact tables, bridge tables, role-playing dimensions, and mini-dimensions. The case studies also show how to design and implement the data warehouse architecture, the data staging area, the data delivery layer, and the metadata, and how to use the data access tools to query, analyze, and visualize the data. The case studies are based on actual data and examples from real-world organizations, and they provide valuable insights and lessons learned from the author's experience and expertise in data warehousing and business intelligence. Conclusion: Star Schema is a book that provides a comprehensive and practical guide to dimensional modeling and data warehousing, and it is a must-read for anyone who wants to learn how to design and build data warehouses that support business intelligence and analytics. The book covers the concepts, principles, and best practices of data modeling, with a focus on the Star Schema, which is the most widely used and effective data model for data warehouses. The book also covers the architectural aspects of data warehousing, such as the data warehouse bus, the data staging area, the data delivery layer, and the data warehouse design process. The book is intended for a technical audience, such as data architects, data modelers, database developers, and business analysts who want to learn how to design and build data warehouses that support business intelligence and analytics. The book assumes some familiarity with relational databases, SQL, and basic data warehousing concepts, but it does not require any prior knowledge of Star Schema or dimensional modeling. The book is divided into 4 parts, which I have summarized in this video. I hope you enjoyed this video, and if you did, please like, share, and subscribe to my channel. Thank you for watching, and see you next time.